Okay, good morning class. So today we're looking at sequence and series, looking at practical applications in particular. We're getting examples for exercise 9. And exercise 9 is on page 23. And this is the example on page 21. Okay. So practical applications. With example 1. So we are given first a introduction to the sum here, where we are told that a red square has sides 12x centimeters. The midpoints are joined to form the green square. So a square, what do we know about this square? All sides are equal, not so. So there we have 12x, and there of course we're going to have 12x as well. Then we are told the midpoints are joined to form the green square. Okay. So of course if this is the square, that's going to stand at 90 degrees. You all agree with that? Okay. And the midpoints, if this is the midpoint, then what is the length from there to there? 6x. And from there to there? Also 6x. Not so. And because this is 90 degrees here, I can actually calculate that length. And how do you think I'm going to calculate that length? Using Pythagoras. It's going to be 6x all squared plus 6x all squared is equal to that side squared. So the side squared is equal to, that's 36x squared plus 36x squared. Give me 72x squared. And if I take the square root thereof to get side on its own, it's going to be 6 root 2 x squared. So the length of the side is actually 6 root 2 x. Not x squared, because I'm taking the square root onto that x squared as well. So 6 root 2 x and so on and so on. Guys, get the idea. Then we are told that the midpoint of the green squares are joined to form the purple square. So again, we take the midpoint here, there, there and there. We join those. So what's the length from there to there now? 3 root 2x. Not so. That's also 3 root 2x. Okay? And of course, it's the square, so that's 90 again. So I'm going to work out this length. Same, Pythagoras again. So it's going to be 3 root 2x squared plus 3 root 2x squared, x squared equals side squared. So 3 root 2 squared, 9 times 2 is 18. X squared plus 18x squared is equal to your side squared. What is 18 plus 18? So that will be 36. X squared is equal to side squared. So the length of those sides are 6x. So I take the square root into account. And so on and so on and so on. You guys understand? So I'm trying to make the purple square. This process is repeated indefinitely. People indefinitely, then what formula comes to mind? Sum to infinity. Which means to say R must be between -1 and 1. Calculate the sum of the area of all the sides of the square. How do you calculate the area of a square? Side times side, not so side squared. And of course, since we have the lengths of the sides there, we can do exactly that. Okay. So let's see. So firstly, what we do is when we get to this practical application, we first set up a number pattern. You guys understand? I set up a sequence or a pattern. Okay, and I use that. Okay, so if we're looking at the area of a square, we see the area is equal to side square to side times side. So the first square is going to be 6x times 6x, not so? So it's going to be 6x squared plus, the second one was, the length of those sides going to be 6 root 2x. 6 root 2x, it must be squared, plus, next one is going to be 6x. With the big one, 12x. So, okay, so they made a mistake there, not so? No problem. We're all people that makes mistakes. Okay, so the first one is going to be 12x all squared plus 6 root 2x all squared plus 6x all squared plus, and so on. Okay? So that's going to give you 144x squared plus 36 times 2 is 72x all squared plus 36x squared plus, and so on. How do you work out the sum to infinity? You use the formula. And what is the formula? A over 1 minus r. A over 1 minus r. What's my a value? One 44x squared over 1 minus, how do you calculate r normally? T2 over T1. So r is going to be 72x squared. Oops. 72x squared over 144x squared. Not so? That cancels. So, let's get the calculator. (72 over 144) is an answer of a half. Correct? Now we say, okay, what is 1? So 1 minus half is half, and 144 divided by half is 288. You must double that. 144 divided by half, 288 x squared. There we go. You guys understand? Any confusion there? Right. Carry on to the next one. Now we're looking at example 2. Example 2 is on page 22. Example 2 is on page 22. So here we are told that at the end of the first year after planting a tree, after the first year of planting, a tree is 1 meter tall. Okay. In the second year, its height increased by 56 centimeters. In each successive year, which means you say each year thereafter, its height increases by 7/8 of the previous year's increase in height. Determine the increase in height of the tree in the third year. Okay. So at the end of the first year, the tree is 1 meter tall. Okay. The second year it increased by 56, so it's 1. Then the next year is going to be 1. So if it's 1 meter, how many centimeters are there in a meter? 100. So I'm going to convert this 1 meter to 100 centimeters rather, so that I got the same SI unit. Otherwise you can work with commas as well. So it's going to be 1, 1,656 and so on and so on. Okay? So it's 100, then 156 and so on. Okay? If you're looking at the increase in height, okay, the first year that is what it is. The second year it was 56, and then the third year it increases by 7/8 of the previous year's increase in height. So 7/8 of 56 in other words. You guys understand? It is not from the 100 or from the 156. No. It is from the previous year's increase in height. Okay. So if I say 7/6 of this value, 7/6 of 56, is that 14? No. So that is going to be the increase in height in the second year. Okay. However, the question is determine the increase in the height of the tree in the third year. So let's go one more. Sorry? So multiply that again by 7/6. 7/8, sorry. Let me give you 42,875. Okay. So at the end of the first year, it was 100, not so. At the end of the second year, it increased by, this is the second year. Going to be 56, and this is going to be the third year. And the question was, determine the increase in height of the tree in the third year. So therefore, it's going to be 49 centimeters. Okay, you guys understand? Alright. Let's look at number 2. Okay, I didn't need it to have gone with 42,87 there as well. Huh? The next one says determine the total height of the tree after 3 years. Determine the total height of the tree after 3 years. So the total height, of course, is going to be, the total height of the tree after the first year is 100, not so. After the second year, 156 centimeters. After the third year, it's going to be this value I'm looking for there, not so. But how do I get to that value? You add 49. So it's 156 plus 49. 156 plus 49. Here's an answer of 205 centimeters or 2,05 meters in height. Does it make sense? Let's look at number 3. Question 3 says, Bello says that at the end of the 5th year, the tree will exceed the height of 3 meters. What does exceed mean? Surplus or more. No? So in other words, he says that at the end of the 5th year, the tree will be taller than 3 meters. That's basically what it says. No? Tabo disagrees with him and says that the tree will only exceed the height of 3 meters after 6 years. Is either of them correct? Justify your answer by means of calculations. Okay. Let's look at number 3. Calculation for number 3. So in other words, I need to know what the height of the tree is after 5 years. And we can conclude is if the Lobelo is correct. Otherwise, we must do it for 6 years to check if Tambo is correct. Do you guys understand? So how do we do this calculation? We're going to say the sum of 5 years is equal to. Now remember, importantly here is that here we got a pattern or a sequence. Not so. And this sequence that 100 does not conform to that sequence. Can you see that? So in other words, after the first year, that doesn't conform, but this is term 1 of the sequence. Not so, that's term 2 of the sequence. This is term 3 of the sequence. But you must also remember that this is actually year 1, and this is year 2, and year. So the first year does not conform to the pattern, while year 2, year 3, year 4 conforms to the pattern. Although year 2 is the term 1 of the sequence. Makes sense?
For the interruption. Latoya Mackler, can you please report to the office? Latoya Mackler.
So with that in mind, I must say, for the first year, for the first year, what is the height of the tree of the first year? 100, correct? Plus. And then how many terms must I have from this pattern or from the sequence? 4. Not so. So how do you work out this the ECN formula for 4 terms? It's going to be A or n minus 1 over r minus 1. Why am I using this formula? Geometry. So what's my A value of the sequence? 56 into r. So how do I move from one term to the next? Multiplied by 7 over 8. This was? Can break or after school? Thanks man. It's going to be 7 over 8. How many terms you said? 4 minus 1 over 7 over 8 minus 1. Okay, so let's go. We say 100 plus 56 into 7 over 8. The exponent 4 minus 1. 7 over 8 minus 1. Can I give you 285, comma, sorry, 39. Okay. So this is to do it, Lobelo. So now, if you're looking at Tambo, so he says after year 6. So is this first person Lobelo correct? No. So Lobelo is incorrect. If you're going to work a sum of 6 terms, of 6 years, sorry, what are we going to change in this formula here? The n. Not so. So that will now become 5. So it's 100 plus 56 into 7 over 8 minus 1 to the exponent 5 minus 1 over 7 over 8 minus 1. So we just change. Oops. 5. See, not playing enough. It's 3,18 centimeters. 3,18 meters, or 318,22 centimeters. So is Tabo correct? So therefore, Tabo is correct. Do you guys understand? See any confusion there? Now the question says, calculate the maximum height to which a tree will grow. People, if we're talking about the maximum height here, that means to say this tree will increase every year by 7/8 of its previous year's increase. But what do you know? What is significant about that 7/8? That 7/8 is lying between which two values? Negative 1 and 1. So it means to say what? This series will converge. Not so. The series will converge. Okay. So we're actually going to work out the sum to infinity here. Not so. The sum to infinity is equal to a over 1 minus r. Okay, but remember, the first year did not conform to this pattern. So what do I say? 1 plus. Now what is the a value in this pattern? 56. What's your r value? 7/8. So it's 56 divided by 1 minus 7/8. The maximum height this tree would reach is 1 plus the fraction 56 over 1 minus 7/8. Gives you 400 and why does it say 1? Must be 100. Not so. 100 centimeters. Because I'm working with centimeters here. So 548 centimeters or 5,48. Alright, you guys understand? Any confusion there? Huh? Okay. Let's do the third example. Sample 3 is on page 222. It says show that 1,9 recurring is equal to 2. So this is in other words like an identity to us, not so. Like an identity, so you must work left hand, right hand side story. Okay? So 1,9 recurring, that means to say that this is going to be, I must write the left hand side of course, no? But write this out, it's going to be 1,999999999. Not so? And that carries on for. Now you guys have done something similar to this in grade 9, eh? You remember? Don't you remember? Who remember? Did we do it with you guys? Okay, we're doing it this year with the current grade 9, so I thought we did it with you. But okay, it's no problem. So if I break this up, I'm going to say this in other words going to be 1 plus 0,9 plus, so that one is out, that's one. 0,99, sorry, 0,09, there's that one, plus 0,009, which is that one, plus 0, 0, 0, 0, 9 plus and so on. Okay. So how long would that go on for? To infinity, not so. But if I look at this, how do I move from one term to the next? Multiply it by 1 over t. Not so. Is that correct? Let's say 0, 0.09 divided by 0.9. 1 over 10. The next one, 1 over 10, 1 over 10, and so on and so on. Okay? I don't move from here to here. Then I multiply that also by 1 over 10. So what do I notice? I notice that that pattern conforms only from there onwards. Not so. And what can we apply here? The sum to infinity. But when we work the sum out here, it's the sum to infinity is going to be a over 1 minus r. But what must be added to this? That 1 there. Okay. So let's do the calculations. It's going to be 1 plus, what's my a value? 0.9 over 1 minus 1 over 10. 1 plus 0.9 over 1 minus 0.1 or 1 over 10. Give you an answer of 2, which is equal to the. Okay. Is there any confusion there? So with that, you should be able to do exercise 9 on page 23 and 24.